Hey guys, I'm Jose and this is tutorial number 17. I'm gonna do tutorial number 17 and 18 quite short in two different ideas that are kind of linked together. One is the idea of writing information, like from our processing sketch we can produce a text file or a CSV file that could be open in Excel. And then eventually number 18 it's gonna be how to read that information and how to bring it in. This is really useful if you want to bring any kind of information from the outside, any information that comes, let's say, in the format of an Excel file or a text file. Eventually we could see even how to bring XML files and stuff like that as well. But for start, just basic idea. I'm going to do it also with a little class, a point class, similar to what we just saw in tutorial 16. So this class will store some of the information of location. So I'm just going to relate this concept to the idea of bringing information from a site, let's say, that could have the point cloud in XYZ and eventually more information, but one step at a time. So first of all, I'm going to do what we usually do, right? It's a basic setup. And we're going to work in 3D here because I'm going to do this point cloud as a grid. And I'm going to talk a little bit about this kind of grid idea as well. Introducing maybe, I believe that it's for the first time, some maybe two-dimensional arrays and stuff like that. So let's do a draw as well. As usual, backgrounds here. Right. So what I want to do, so I'm gonna first of all I'm gonna save this file. This is gonna be my desktop tutorial 17. Right. And I'm gonna do a new tab that it will be called point. Again, if you're not familiar how to do a class, we define the name of the class, and then we define the constructor, and that is the information that we need to provide in order for this class to start functioning, how to initialize it. Here we can put the global variables. Here we won't put location equals underscore location, equalizing the information that comes outside the class, like passed into the class with our global variable log, so we can use location in any point. And I'm gonna write, as usual again, run, outlining our behavior, display. Right, so we're going to do a little point. In this case, it would be location.x, location.y, location.z, right? So, and the color, let's say something like red. So, first thing is the things of class, nothing too special, just the fact that it has a location. So I'm gonna do, bring in like toxic loop library. I'm gonna copy it from some script that I have open somewhere around. So we're gonna import the toxic loops library, and we should have a 3D environment. We can't see it yet. Let's see it. So I'm gonna do, this is stuff that we have done in previous tutorials, so I'm just gonna go through it. You can just copy some of the code. I'm gonna import PCCam. I'm gonna do an instance of PCCam. Oops. What I'm doing here is bringing an external library that controls the camera movement. And so we will have zoom, pan, and rotate. So now I'm going to draw a little box in the screen so we can really see what we have. A box of 600 and stroke of 255. Right? Quite straightforward. And right, so we have a 3D box that we can move around with the mouse. Great. So this is kind of almost a template for me to really start working on some of the behavior, or like in this case, what we want to bring in. So what I want to do is define something like a grid of points. So I'm going to define an integer that will be cols, 20, and an integer called rows. So columns and rows, right? So because we're doing a grid, we're going to need columns and rows. And then we're going to do a two-dimensional array. What is a two-dimensional array? It's a collection, but it has it's like, you could imagine it as a egg crate, where you can have rows and columns to store information. In this case, what are we going to store inside? Our points. So each position in the egg crate would be a point. So we're going to say point grid. This is the name of our variable. And we're going to use these square brackets to explain that it's a two-dimensional array. Equals, equals new point, and we're going to say cols and rows. Right, so here what we're saying is the size of the array. You can go through the array algebra, it's the same thing, but we're defining another dimension of it. You can do as many dimensions, I believe. I've tried it with three-dimensional array, but not 4, so I don't know. But probably you can do more. So this is the definition of how big that array is. So it's 20 by 20. Now we can actually do a little for loop. For integer I equals 0, I smaller than columns. Right, so we're gonna go through our columns, and what are we gonna do for each element in this collection? If you imagine that one for loop allows us to generate a repetition that, let's say, of points, it would be like a sequence in a line, right? If we want to eventually produce a grid, we need, for each one of those points in a sequence in a line, we need to produce a sequence of points going down. So for that we introduce the idea of a nested for loop, right? So for integer j, because I can't repeat the name of the variable, j is smaller than rows, j++, right? So that structure allows me to build a grid. I just press Command T or Control T in your PC in order to auto format the text. And now I can say grid I j. So this will be each one of those elements in that grid. It's a new point and I need to provide a vector here. In this parenthesis here, I need to provide a vector. So let's provide a vector. We're going to say vec 3D equals new vec 3D. And what is the location that we want to give to each one of the points? Let's say the first one, when I and j are 0, both of them, I want to put this guy in 0, 0 coordinate, right? So I could put here, if I put 0, 0, 0, this means that all the points would be in the same position. So I want them to change. I would use I here and j here, and this will start changing. This will go from 0 to 20, so I would have a sequence of points 0 to 20, and then the location in y will also be changing, first in 0, then in like 1, 2, so I would have a grid. But this grid would be quite tiny, so I can, in order to scale this up to whatever size I want, I can do another kind of variable that I'm gonna call grid size equals step, right? So if I multiply I times grid size and j times grid size, this means that the location of the first point will be 0 times grid size 0, j times 0, right? So the first one will be 0, 0. 1 times grid size will be 10, same for j, and so on. I mean, we will be jumping 0, 10, 20, 30. So the scale, the grid size, it's kind of the factor that would define the scale of the grid. I and j is just the counting. So that's going to be the location of the points. And I'm going to say, oh sorry, I didn't name this variable. I'm going to say point location. So point location here is the vector that we use for our class. The only thing that we're missing is to run this class, right? So I'm going to do a little bit of space here. What do we need to run this class? Because we're basically calling 20 times 20 points, right? So to call the function run in each one of them, we need to access our two-dimensional array. So I'm going to copy this for loop structure. This is the way we can access each one of them, right? And not just one. And I'm going to say grid, so that's our element, each one of them, dot run. It's the same thing that we have been doing, in this case, like as we did with the array, in tutorial 5, I believe. We're doing it for each one of the elements in this grid. So let's see if we're having any errors at this stage, and if this is working. Right, so it is working. We have a grid, but it's located, the first point is located in 0, 0, and the last point, it must be 20 times 10, it's 200, 200, right? The good idea, a good interesting thing about this is that if you would put grid size 1, you can see that our grid is now a tiny grid, right? So that allows you to, really the grid scale allows you to scale this up and down. You can see that our 0 here, it's quite boring. We're producing a plane. So why don't we add a little bit of some extra information. So I could say float set, right, equals random from 0 to 40, right? So this would produce a variable called set, and that it's a random value between 0 and 40. And I'm going to put set here. It's important that we put it here. So if we check now what we have, what do we have? We have a series of points that are just kind of scattered around. So that's interesting. We have that. We're gonna use this setup to do many tutorials on, like, say, cellular automata and meshes and a few other things, you know, even reaction diffusion. I mean, we could go through that. But at this stage, what I want to do is explain how can we export this information. Let's say we want to record a file, and then eventually in the next tutorial we'll see how to bring it in, right? So to export this data, I'm going to save. We're going to call this line of code that says screenwriter output. This is a class that is already embedded in processing, so we can just use it. And that allows us to really to open an output file that we will specify where it is, and afterwards we can print information in that file. Okay, so we're going to say output equals create writer, and we're going to say the name of where do we want this file to be, data slash points .csv. I really like the CSV format because this CSV format is a comma separated file. That means that the information is modulated automatically by commas. If we use commas to determine different fields, we can open this in Excel or in numbers, and this could be sorted in different fields in the program, right? So I think it's really useful. We can and we'll see how to bring them in a similar fashion, like looking at different cells to provide the information. So what we're doing with this line is opening a blank file, and we need to now say something like, okay, if something happens, we will record some information into that file, right? So let's say void, and actually we can do it here inside the draw, so it's simple. Just make sure that you do it outside the for loop, so the last curly brackets of the draw function, it's here, and we're gonna say if key pressed, right? So if there's any key in the keyword pressed, we're gonna, what can we do? We could say output dot print line, and we're gonna print something like test, right? And there's a few lines that we have to add, that it's output dot flush and output dot close. This is for closing the file and leaving it ready for us to work with. Again, I'm gonna save this and we're gonna try it. Right, so we have our script. I'm gonna press some key in the keyboard, and that should be good. Now I have the folder here, tutorial 17, right? So I will open it up, bring it into the window, and we would see, if you would have checked this folder before we actually did that, that this folder called data didn't exist at all. Processing generated a folder called data, where inside he made this file called CSV, and that contains the information that we wrote. So I'm going to open it to see what do we have in there. It's loading it up. Okay, So very simple file. So we wrote a line of code, a line that says test, right? JOSE. If we would delete this folder, we will see that if we would run this again, the same file would get generated. So instead of writing the line test, we want to write something else, right? We want to write each and one of the coordinates of each of the points. So I'm going to copy this structure here that is for looping through the points, right? So what I'm going to do is repeat for each one of the points. I'm going to repeat this line print something, right? And I want to write here the location in X of the point, the location in Y, and the location in Z. So this line here tells us this is the point, right? We're going to copy that. So that's the point. I'm going to make a little bit of space so you can understand what are we looking at here. So that's the point. We can access the location vector of the point and the X component of the location vector, right? So that would print for each one of the points the location in X. But that's not enough. We need to add the plus in order to add more information, and we're going to add a comma like this, because what we're writing here is a string, basically. It's converting this information in a string, basically characters, and we're going to add a comma into that string, then again a plus to add more information, and we're going to copy the same thing in Y. Similar thing, comma, plus, and set, right? So what we're saying here is go through each one of the points and print a line of code that is the location in X, then separate them by a comma and each one of the components of the vector. Because it's a comma separated file, let's say first, it should be organized as an Excel or as a spreadsheet, right? So we have our system here. I'm gonna press enter. You could add a little function here like print line right. So in this way you would know that when you press a key, right, if I press a key, you would see here a little warning saying, hey, you call this function, right? So if we would go and see inside our folder, the data folder has been created again, and we would have another CSV file here. We will open it. I open it with Excel this time, sorry. It should be the same thing. Right, so this is what we're getting at this stage. We're getting the coordinate in X, the coordinate in Y, and the coordinate in Z. You can see a sequence goes like this. 0 in X. We keep counting in Y. In X we have a random from 0 to 40. And we go through all the points like that. So that's great. In the next tutorial we're going to see how to, using that CSV file, so try to get it to work, how to import it into our script. Okay.